Hello again, everybody. In this next session, we would like to present an update on the progress we have made targeting the performance of the Mojaloop platform over the last project increment. Next slide, thank you. A quick recap. This work stream addresses two of the fundamental pillars that have been mentioned and discussed already this week. Firstly, making adoption easier. And secondly, quality product. Our objectives at a very high level have been to bring the cost of transactions as close to zero as possible. We know that's one of our inclusive principles, and we're trying to do this by reducing the total cost of ownership of a Mojaloop platform. And we're also trying to facilitate, enable scheme operators to start small at low cost and scale in an efficient way as traffic increases. We're trying to do this by improving the overall efficiency of the software systems and the way they interact with the hardware. In the next few slides, I'm going to talk a little bit about some of the detailed objectives. At the start of this PI, at the end of the last PI, we spent a considerable amount of time thinking about how to do this, what was important to us and what wasn't so important to us, and the methodology we would use. There's a lot of detail in these coming slides. I'm going to skip over most of it, but it's in there because these slides are going to be shared after this event. So if you're technically minded and you care about the details, I'd encourage you to read through those in a bit more detail if you want to understand more about this process we're going through. Sorry, could you just go back one second? Thank you. We have made considerable amount of progress in this last PI, characterizing, running a first pass of optimizations against all three phases of a Mojaloop transfer. The discovery phase, the agreement phase, and the transfers phase. All of the optimizations that have been made during this previous PI are lined up for the pending release, which is called Acacia. We can expect that release to be made in the coming days. It probably would have already been made had it not been for the PI convening event being this week. I know Sam is working hard to get the release tested and out to our community, so you should expect that in the coming days. There are some further follow-ups that we'll talk about more, that we are going to conduct over the coming weeks and months of the next PI. And we have this previous PI spent a deal of focus on bare metal. Historically, Mojaloop development and testing has been conducted mostly in public cloud because of cost and efficiencies. But our adoption community increasingly are limited by regulation and desire for system platform data sovereignty. They wish to host their switch platform infrastructure in private data centers, either private cloud or bare metal or some virtualization technology. So we've done a considerable amount of work to try to take that into account and understand how the Mojaloop software works in those various environments and to inform our future direction. Going forward, we're always looking for more resource to help us with this. It's a continual area of focus for the Mojaloop community, the engineers on the project. We're always looking to optimize and improve the non-functional aspects of the platform. There's some especially significant work coming up in another work stream that Pedro Barreto is going to present on later this week, which we hope will also bring some further performance optimizations. So let's move on to the next slide. Our number one priority and objective when we started this process was to make sure we could hit a target of 1,000 transactions per second, sustained for a period of 1 hour. with less than 1% of those transactions taking more than 1 second, and also with 0% unexpected errors. And that whole process running, as I said, over 1 hour and being durable. We set out by giving ourselves some definitions. We define a modular loop transaction as an address lookup, followed by a quote, followed by a transfer. So those 3 steps happening end to end, one after the other. We did say that if we struggled to achieve that target on a reasonable volume of hardware, we would immediately prioritize looking for some low-hanging fruit in the code base to find any obvious inefficiencies that we could, with limited amount of resource, effort, and time, remove those bottlenecks to move us further towards our goal. Can I have the next slide, please? Thank you. Apologies if you can't read this. As I said, there's an awful lot of detail in here. Please do feel free to read this in detail after the show. A few important points to note, though. The test tool chain that we needed to build as part of this work stream, we want to be reusable. We want that to be value that's carried forward in the modular loop community for a long, long time. We want to be able to repeat this performance testing. So we know as we evolve and change and modify the code into the future that we can measure the performance of the system in all sorts of important ways, so we understand the impact our changes are having on total cost of ownership, cost per transaction. We need to monitor that as time goes by to make sure we're not creeping in the wrong direction and that we're always trying to narrow in, target that 0 cost per transaction. Next slide, please. Thank you. So slightly longer term, and our second priority for this work stream is to introduce these performance tests into our continuous integration pipeline. Many of you will be familiar with more modern development processes, which employ continuous and automated build steps. Once a code change is committed into a code repository, various tests, checks are performed against the code. Right now, we don't automatically perform any performance tests as part of that process. They're a manual thing. It takes a developer a conscious effort to load and run that test suite to understand the performance of the code before and after a change. We're going to automate that. We're going to build that in as part of our CI pipeline. We also want to publish those metrics in a clearly visible place. Our build reports all end up on GitHub at the moment. Part of the GitHub tool chain publishes our build results, gives us a list of test passes and test failures. That's freely available to anybody who wants to come and understand how the system quality is after any particular code change. We'd like to include those performance metrics in those reports as well going forward. So at this point, I'm going to hand over to Warren from Infotex. Infotex have donated a considerable amount of their time and resource over the previous PI to this effort. So I'd like to thank them for that. Thank you, Warren. Over to you.
Thanks, James. All right, so Vijay and myself will be a bit of a tag team on this. Vijay is the solution architect at Infotex that's been working on the performance enhancements. So as James said, we were targeting what does it take to show that we can do 1,000 TPS, because we showed we could do 1,000 TPS back in the day several times, and in some cases many more. But what we needed to do was make sure that the code that had been evolving over this time had a standard way of being tested and validated for that. And we want to make sure that's part of our continuous build process. So we took an iterative approach here, time box, no one's got infinite time, and we made sure that we could target each of those channels individually and put them back together and make sure the whole thing hung together. And the repeatable tool set was very important. And Vijay will mention that a bit later around the tool chains that we have. Next slide, please.
Hello, everyone. My name is Vijay Kumar. I'm working for Infitex as a solution architect. So, yeah, before going to the slide, I have to mention that working on the performance stream is very feeling good about that, because we always like the numbers, right? So when we do some optimization and see that in real time, like increment in the performance, yeah, the feeling, it was very good, and I enjoyed working on the performance stream. So we chose K6 as a load generation tool instead of JMeter, because there are some reasons, and we spent some time researching on the tools. And I think nowadays, yeah, I heard a lot of thing about K6. So nowadays everyone is using that. Here, if we see this diagram, I made that very generic. So on the left-hand side, K6 is there. It simulates the DFSP. It generates the load as a pair DFSP. On the right-hand side, we have very lightweight simulator, which is Node.js-based simulator. It just responds with the hard-coded callbacks. So K6 generates the load, and it passes through the module loop implementation, and simulator responds with the callback, and we get metrics on the dashboards. K6, we have nice Grafana dashboards provided by K6. So in the middle, we can put anything there. I mean, any implementation of the module loop, which supports the FSP API. Right? Next slide, please.
Yeah. So just to cut to the chase, we'll go back to some of the details. But we discovered a few things. Some of them were pretty embarrassing. Somebody had a log statement without an if clause around it, and it was a horrible log statement. So we discovered things in the discovery phase where actually we were hiding things from ourselves as a community, because we just turned up the number of nodes in Kubernetes very easily. It's great, except if you want to be efficient. So the discovery phase went from 10 ops a second, yeah, ops being the full return path, to 100. We know that that scales nicely up to, for instances, does slightly better. And we know that actually there were a whole lot of other little bugs we found in that process. Remember, I said we time boxed the effort, but we could see a whole lot of other things. Then we did a POC around it. We were doing 400 operations. So little things to pick up. The agreement phase, that's doing quotes through the system. Again, similarly, we were just upping the number of nodes. Just took a look at each node separately on that single hardware instance, and went to, by the time we were finished addressing the silly things, 177 ops. And transfers is a little more detailed story. And we'll go into that later about where the obvious bottleneck in the system is around managing positions. That was doing 95 ops, and it ended up doing 233 ops on the transfer leg. That is complicated and a mix of a lot of individual services. So yeah, we'll go through those details. So these are just numbers where it's running as a single instance. This is plug and playable, so we can put updates and other versions of FSP IOP implementations into it. It's all running in a single environment that's going to fit inside our CI/CD pipeline. And obviously, we had to make sure we could put this together. So if we go to the next slide, we said, okay, before when we did 1,000 TPS, we were actually just looking at that transfer leg. So what happens now if we take that same hardware stack and just make sure we're doing the discovery, the agreement, and the transfers all together. Single node load generation on the node as well. In fact, that became a bit of a issue in itself because it was consuming resources, but that was doing about 220 financial transactions per second, the label we gave that full wraparound. So that is on a server which is, not too dissimilar to some of our laptops these days. So that's not a bad baseline. I'll let Vijay go through the following slides, but Vijay, we only have 5 minutes, so.
So hosting progression. So we started with very simple module loop deployment, which is Docker Compose. There is a repository, ML core test harness in the module loop Git. So we can deploy module loop core services using this Docker stack. So we started that, with that, and we analyzed the performance and did some optimizations, and it's an iterative process. And then currently we're testing the module loop deployment through the Kubernetes. So when I say Kubernetes, it is both Helm-based deployment, manual Helm deployments, and also we're testing it in IAC-based deployment. So that is in progress, and our next plan is to scale the Kubernetes pods and get the benchmark, and then we include SDK, like payment managers on both sides, and get the benchmarks, and finally we will test it with the MTLS and JWS enabled. Next slide, please. So as part of the stream, we added many metrics, missing metrics in the module loop core services, and also we added new dashboards and updated the existing dashboards to support new metrics. And we got some automated scripts to execute the performance tests and capture the results. As James mentioned before, that is one of the objectives. We need to automate the performance tests in the release cycle. Yeah.
I think it's worth saying all of these are actually captured in the GitHub repositories. There's lots of links to them as well, so you can look at it. We don't have time to go through them all now, though.
Yeah, we have a dedicated slide at the end with all the references, so you can get all the dashboard, all the captures, results of the dashboards, and also the releases we made. Yeah, next slide, please.
All right. So there's a more detailed look at the discovery phase and the agreement phase and the transfer phase with these schematics, also all documented in GitHub. If we can go through the 2 slides. And again. Okay, so this is the transfer phase, which obviously the most complicated part of the processing. And those are the numbers you saw earlier relate to running this through end to end. So what next? Next slide. Oh, one more. Okay. So obviously in this implementation and version of the transfer processing, the central ledger position handler is the hotspot. That's where we're managing the position for each of the DFSPs to make sure nobody spends, nobody creates a greater obligation than they are entitled to, and we have to make sure that for every transaction that is actually realized. So we have, the one is in green. That's because we've actually implemented the changes there that were in fact designed in 2018. And we are going to finish the job on the position handler for the full leg. But Vijay can just share with you those results on the prepared leg at the moment. Next slide.
Okay, so why position handler? because we observed the bottleneck, real bottleneck there, because we locked the positions of DFSP. That's why we implemented the batching. I'm not saying we implemented the batching because there is there was already batching implementation in the central ledger, but we found some gaps. That's why we redesigned the batching. So you can go through the detail. So the diagram here, we got nice documentation. All the links are in the references slide. So if you see the numbers here, so operations here means it's not transfers, I have to say. So this is an operation means a single processing of a single Kafka message by the handler. So there are multiple messages involved in a transfer. So, but we can see the difference. Without batching, 183 operations per second. If we enable batching with batch size of 10, it went up to 1.1 K. And with batch size of 100, we got 2,200 operations per second. Yeah, so which is a very substantial difference. So yeah, and also you can observe the latency when we enable batching. It's not too bad.
Yeah, thank you, Vijay. So it's our plan to just finish that for full handler in the next few weeks, and the idea is that this one will leave the Arcadia release in a much better shape, but also it gives us the tools that we can take forward with us to make sure we keep validating performance and efficiency of the platform. Okay. Thank you very much, James.
Thank you.
Yeah, thank you. Thanks again to the Infotex team for donating their time and effort on this. It's very valuable. Thank you. Does anyone have any questions at this point? Yes. Sorry, Simeon, can you manage questions? I think the battery might be flat in that one. Thanks.
Thank you. I'm not sure this is the right stage to ask this question. I'm just worried about the current release of Moja Loop. Does it have metadata like, can we be able to extract from the transactions metadata like age, sex, so that we can have demographic elements? We can data mine and we can process it for further manipulation. And are we able to do creditworthiness data if, for example, in our case, micro, small, and medium enterprises, they don't even have bank account, and if they bring their roving capital to the platform and they want to transact as many times as possible, are we able to give them statements so that they can take it to Access Finance? Thank you.
I know we have some experts on that kind of issue in the room who might want to step in at this point. Please raise your hand if you do. I know Michael might have something to say. Miller.
I can give you a high-level comment, which is that the Moja Loop design is such that the transaction object is flexible to implementation. The switch does not depend on details in the transaction object. So if you choose to carry that information, desegregated by, I'd say sex disaggregated data or geography information and other things in the transaction object in a way that is retrievable by your metadata extractor, it can sit on the side. It could be a sidecar, or it could be actually a retrofit to the system itself. At present, the transaction options slide through the system, and eventually it turns into a transfer where the money moves. And during the transfer process, that detail is generally not used, even though it might still be available at that point. That would be at a high level, but I'll defer to Michael on details.
Yeah, thanks, Miller. It's certainly true that the scheme can choose which data elements they can require a participant to send and Also, regulators are free to specify the data controls that must be employed by the scheme operator to set further restrictions on that. There's lots of data privacy laws that exist around the world now. The Mojaloop platform facilitates, as Miller said, through the flexibility of this transaction object that gets passed around, how that data is handled. So from keeping data on disk persistently in an encrypted storage forever to destroying that data immediately after a transaction is completed, we have the wealth of options in between those two extremes, if you like. Does that answer? Okay.
Can I just add a little bit to that, which is to say that one of the enhancements that I think will be in the next release of Mojaloop will be an all-purpose field, which which will be attached optionally to every party to a transaction, and it will be up to the scheme to say this is the information that we want participants to include in that field. So, for instance, if you wanted information like gender or date of birth or anything like that, you can just say to your participants, you must include this, and this is the format in which you are to include it. I want to circle back on the question of credit scoring to say that one of the things that Mojaloop kind of doesn't want to do is to, how can I put this, is to nail down who is transacting. In our world, that's a matter for the owning DFSP to know. So when we send an identifier which says this national ID, this mail address, this phone number, we're actually sending something to the owning institution, the mobile money system or the bank or whatever, that says, if I gave you this identifier, would you know which account to credit? And if the owning institution says, yeah, I accept that, that's a way of saying, I know how to accredit a particular account. But there is nothing in the metadata in the Mojaloop system that says, for instance, the national ID 123456 and the mail address mike@richards.com belong to the same person. They're just two different identifiers that my bank or my mobile money company knows how to route to payment to a particular account. If you want to be able to do credit scoring, then your scheme, I think, will need to require information from the DFSPs to say all of these transfers, which were in the Mojaloop scheme tagged as being with these particular different identifiers, in fact belong to the same account. Now that's, of course, is by no means difficult. It's just something that Mojaloop by design doesn't do.
Thank you, Michael. I think we've run out of time now. If there are any further questions, we'll be happy to answer.
Can I just see by show of hands how many questions are in the room? I'll just take the one more,
Okay.
but kind of keep it short because we're over time. Thank you.
Thank you, and thanks for the presentation. My question is fairly simple. I just wanted to appreciate if at the point of getting the transactions per second set, it was with the full overhead of the validations and security, or we didn't have those overheads, just so we can put in that missing link to the numbers that we arrived at. Thank you.
Yeah, that's a good question. That I think we tried to explain. We probably didn't do a good job. So the initial testing was done on isolated components. Now, some of those components have elements of the security, for example, validating the ILP, the interledger packets, and some of them don't. The ALS service, for instance, it's just a simple database lookup. So it's not an easy question to answer. The roadmap that Vijay talked about, the arc of progress that we're making through the test process is towards the full end-to-end. The final chunk in that was to do the full end-to-end with all the mutual TLS, the website JWS signing, the ILP, or the full end-to-end test. So the number of 1,000 TPS, that's our target, that is with everything switched on, the full kit and caboodle, all the redundancy, the replication of the databases, everything that you would switch on in a production modular loop instance. That's our target. Thank you.
Thank you so much. Paul, I know you're on Zoom with a quick comment. I can give you the last statement here. Paul Macon.
No, thank you. I just wanted to highlight a few concerns about adding all of that data onto the transaction. It gives me severe pause for thought, because remember, you're adding a lot of personal identifying information onto a transaction, where the other requirements in operating a Mojulu hub say we've got to keep those transaction records for 5 years, which gives us rise to a serious data privacy concern. Not just because whoever is authorized to access the hub data records can see everything that you have done, every single transaction you've been involved in, but consider those cases where the hub is operating in a country where the government is less than benevolent and seeks to identify the transactions carried out by members of the opposition. Do you really want all that data held in the hub? Just a thought.
Thanks for lighting that, Paul. Allow me to bring this to a close. Thank you, Warren, Vijay, and James. A round of applause for that.
Thanks, everyone.